Hello, welcome to my Advent Calendar 2024. I'm Noah Man. I'm the author of functionalj.io, which is a Java library that brings functional goodies to Java. I wish to use this series of video to showcase functional J capability and how it can help you write more functional code in Java. Today's question will be day 3. All the code discussed in this video and all the link will be in the description of this video. Let's get started. As we were looking for the chief historian, we went to the North Pole tobacco rental shop and they were having computer problem. It seems like their programs are corrupted. Their program supposed to tell multiplication of two numbers, x and y, and they want to know the result of the multiplication. In this case is 44 and 46, and the result is 2024. But because the program is corrupted in the memory, so we're supposed to ignore all the command that is not properly formed. Something like these. Have some non-number and not close. Have no close. Have no mull in the front. Or have extra space. In those cases, we do not think. So let's say we have this program. So all the white highlights are those that are properly formed. Like this, like this, and like this. So what they want from us is to find all the total summation of the multiplication. So 2 times 4, 2 times 4, 5 times 5, 11 times 8, and 8 times 5. Sum them all. And in this case, we get 161. That's the question. Let's see the code. So in this code, start from calculate. So we get all the lines from the files and then map each line into the total line number. So we process them line by line. And for each line, I use this regular expression to grab the pattern. Then for each line, I process again and only grab the number. So after we grab this text, we grab again for only the number. Convert that string of numbers into the actual numbers and then multiply them all together. With the result, we get integer, which we turn here and we sum them all per line and we sum again for all the results. With functional J, you can write the program in the functional style, which allow you to format the code in a different way, in a more descriptive way. So hopefully this is one of the way we can describe the program exactly what we think it should do. That's it for part 1. For part 2, as you scan through the corrupted memory, you notice that some of the condition statements are still there. If you handle some of these uncorrupted conditional statements in the program, you might be able to get an even more accurate result. If you see the condition do, that means the subsequent mull instruction will be enabled. But if you see don't, that means it will be disabled. Only the mull instruction that come after do will be accounted for, right? So at the beginning, the program mull instruction are enabled. So in this case, this one is enabled. And then when we see don't, so this one is not enabled. This one also not. Okay, this one is malformed. This one is not enabled. Then we see do again, and this one become enabled. So the result is only 2 by 4 and 8 by 5, right? Only 2 of these enabled. Now take a look at the code. Because the input data comes in multiple lines, the disable that we might face at the end of one line will affect the mull instruction in the next line. So we will have to process all the code as a single piece of code. So we start with joining them with the space like this and then process them. I use a different technique to make the code more understandable. And that is to use comment, which focus on example, not what it does. The code should explain what it does, and the example should enhance that. In this case, there are 5 steps, A, B, C, and D. So if the input's coming in this way, which is the same with the example that we have, the first thing we do is to add do in the beginning. And that because we want to enable the processing by default. And then we segment all this code after this command. Okay, let's go back a little bit. After this command, the list is filled with whatever matching this. Why don't we do this? Why don't we pick C? Okay, so let me disable this one for now. There's going to be a lot of data there. So as you can see from this example data, right, you can see that it found the match 2.4, it found the don't, it found Mull 5.5, it found Mull 11.8, it found do, and it found Mull 8.5. Okay, so that's what it found. So the code become do, Mull, don't, Mull, do, Mull. So when we segment the code with do, what we get is do Mull. Okay, sorry. We segment the code that the commands start with do, which include do and don't. So we get do this, don't that, and do this. We move this one down here. We'll see that is do Mull, don't Mull, and do Mull. Okay. From that, the next step is C. We just exclude any segment that start with don't. Right? So from here, it will reduce to just do. Okay, so now with only two of the do's and none of the don't. And then for each segment, we perform a segment sum. So how many mark instruction in that do segment, we just perform the multiply for each and then sum them all, which the code looks something like this. From the segment, we skip the first one, which is the do, and then we calculate each of the mole. The result will be integer, so that's why I map to int, and then we sum it at the end. And after that, we sum the result from each of the segment. Right, so this do, and then segment sum, which is just this 2 here, get 8, that 8.5, get 40, and then sum, get 40 at the end. So functional lists actually make use of stream behind the scene. So you don't need to call stream. The functional list can be used to do all this operation by themselves. That's it for today. I hope you see some capability of functional J. Again, I will put all of the link to functional J and a code in today's question in the description. Thank you. Bye-bye.